Good morning to everyone. Myself Tanmay, you know very well. I am taking class about 2 weeks. Okay. Can you see the questions clearly? Can you see the questions clearly? Let's solve the first question of the substitution method. Okay. Question is y is equal to cos inverse 1 minus x square by 1 plus x square. You tell me how a square minus x square by a square plus x square, which value I shall put. First write implies y is equal to cos inverse 1 minus x square by 1 plus x square. Okay, let x is equal to tan theta. You can tell me how I know that in place of x I can write tan theta. Because of only practice, and you know tan 2 theta is equal to cos 2 theta is equal to 1 minus tan square theta by 1 plus tan square theta. Just compare and tell, is this is same? Yes, it is same. Only in place of tan theta it is x. So implies y is equal to cos inverse 1 minus tan square theta by 1 plus tan square theta. Okay, implies y is equal to cos inverse of cos 2 theta. Implies y is equal to 2 theta. You know that x equals to tan theta, implies theta is equal to tan inverse x. Okay, implies y is equal to 2 tan inverse x. Differentiating both the sides with respect to x, we get dy upon dx is equal to d by dx of 2 tan inverse x. Implies dy upon dx is equal to 2 constant comes outside, dy by dx of tan inverse x. Implies dy by dx is equal to 2 by 1 plus x square, and this is your final answer. Okay, see next question is y is equal to sin inverse 1 minus x square by 1 plus x square. Let's see how can we do it. Implies y is equal to sin inverse 1 minus x square by 1 plus x square. Okay, here let x equals to tan theta. Implies theta is equal to tan inverse x. X is tan theta. If theta you can find the value of theta, then tan will be coming here by tan inverse. Y is equal to sin inverse 1 minus x minus 1 minus tan square theta by 1 plus tan square theta. Y is equal to sin inverse of cos 2 theta. Y is equal to sin inverse of sin pi by 2 minus 2 theta. Y is equal to pi by 2 minus 2 theta. Y is equal to pi by 2 minus 2 tan inverse x theta value. Differentiating both the sides with respect to x, we get dy by dx equals to dy by dx of pi by 2 minus 2 tan inverse x, implies dy by dx is equal to dy by dx of pi by 2 minus dy by dx of 2 tan inverse x. Okay, implies dy by dx is equal to 0 minus 2 dy by dx of tan inverse x. So dy by dx is equal to minus 2 by 1 plus x square. Okay, done. Answer. Third question. Let's see how can you solve this question. Question is y is equal to cos inverse 2x by 1 plus x square. This is all an NCERT question. Okay, write the question clearly. Y is equal to cos inverse 2x by 1 plus x square, implies y is equal to cos inverse 2x by 1 plus x square. Let x equals to tan theta. Y is equal to cos inverse 2 tan theta by 1 plus tan square theta. Y is equal to cos inverse y is equal to 2 tan theta. Let's see, here x is equal to tan theta, so 2 tan theta by 1 plus tan square theta, that is sin 2 theta. This formula. Okay, y is equal to cos inverse cos pi by 2 minus 2 theta is equal to y is equal to pi by 2. You can tell the value theta is equal to tan inverse x. Y is equal to pi by 2 minus 2 tan inverse x. Differentiating both the sides with respect to x, we get dy upon dx equals to dy by dx of pi by 2 minus 2 tan inverse x. Okay, so dy upon dx is equal to dy by dx of pi by 2 minus dy by dx of 2 tan inverse x. So dy upon dx is equal to 0. This comes to outside, dy by dx of tan inverse x. Dy upon dx is equal to minus 2 by 1 plus x square. This is the final answer. Okay, write it clearly. Write it down. Waiting. For logarithm differentiation question, don't worry about that. I will surely solve logarithm differentiation till two videos. Okay, after covering all subtopics, then I will start PYQ. Okay, don't worry about that. This is fourth question of NCERT and this is last question of NCERT. Okay, not today's last question, NCERT last question. Y is equal to sec inverse 2x square minus 1. How can you do it? Implies y is equal to sec inverse 1 upon 2x square minus 1. Y is equal to cos inverse 2x square minus 1. Y is equal to cos inverse, let x equals to cos theta. Implies theta is equal to cos inverse x into cos square theta minus 1. Y is equal to cos inverse of cos 2 theta. Y is equal to 2 theta. Y is equal to 2 cos inverse x. You have to write differentiating both sides with respect to x. dy by dx equal dy by dx of 2 cos inverse x. dy by dx is equal to 2 dy by dx of cos inverse x, and dy by dx is equal to 2 by minus 2 by 1 minus x square. This is the final answer. Write it clearly. After that I will solve some proof type questions. Okay, read the next question. This is proof type question. If y is equal to sec inverse root x plus 1 by root x minus 1 plus sin inverse root x minus 1 by root x plus 1, and then prove that dy by dx is 0. This is minus. Okay, and dy by dx is 0. How can you prove this? Let's see. First, in proof type question, you have to write given that y is equal to sec inverse root x plus 1 by root x minus 1 plus sin inverse root x minus 1 by root x plus 1. Okay, implies y is equal to cos inverse root x minus 1 by root x plus 1 plus sin inverse root x minus 1 by root x plus 1. You know sec inverse x is equal to 1 by cos inverse x. Okay, again we also know that cos inverse x plus sin inverse x is equal to pi by 2. So y is equal to pi by 2. By differentiating both the sides with respect to x, we get dy by dx is equal to dy by dx of pi by 2, imply dy by dx is equal to 0. This is 2 mark questions. Okay, write it clearly. Again I am reading question. If y is equal to sec inverse root x plus 1 by root x minus 1 plus sin inverse root x minus 1 by root x plus 1, then show that dy by dx is equal to 0. You have to solve in this way. Next question. Let if root 1 minus x square plus root 1 minus y square is equal to a whole into x minus y, then show that dy by dx is equal to root over of 1 minus y square by 1 minus x square. This is the CBSE previous year question, in which exactly I don't know, but this is the previous year question. Okay, and given that root 1 minus x square plus root 1 minus y square and a whole into x minus y, let x is equal to sin alpha, let x is equal to sin alpha and y is equal to sin beta. Okay, therefore root over of implies here alpha will be sin inverse x, your beta will be sin inverse y. So root over 1 minus sin square alpha plus 1 minus sin square beta is equal to a times of sin alpha minus sin beta. Okay, root over of cos square alpha plus root over of cos square beta is equal to a sin alpha minus sin beta. Okay, cos alpha plus cos beta A sin alpha minus sin beta. Okay. Here cos C plus cos D formula. You have learned in class 11. What is the value? What is the formula of cos C plus D? Cos D. 2 cos alpha plus beta by 2 into cos into sin alpha minus beta by 2. Okay. Sorry. Cos C plus cos D is cos. Okay. Cos alpha minus beta by 2 is equal to A sin C minus sin D. A into 2 cos alpha plus beta by 2 sin alpha minus beta by 2. Okay. 2 cancel, cos cancel, cos function cancel. So cot alpha minus beta by 2 is equal to 1. Okay. Here alpha is sin inverse x minus sin inverse y is by 2. Okay. Cot bracket alpha minus beta by 2 is equal to A. Implies alpha minus beta by 2 is equal to cot inverse A. Implies alpha minus beta is equal to 2 cot inverse A. Difference implies alpha is sin inverse x minus sin inverse y equal to 2 cot inverse A. Differentiating both the sides with respect to x, we get d by dx of sin inverse x minus sin inverse y d by dx of 2 cot inverse A. Derivative sin inverse root over root 1 minus x square minus 1 minus root over 1 minus y square dy upon dx is equal to 0. Here dy upon dx is equal to root 1 minus y square divided by 1 minus x square. Proved. Okay. Clear? Write it down. Again I am reading question. Root over of 1 minus x square plus 1 minus y square is equal to a whole into x minus y. Derivative find then so that dy by dx x is equal to 1 minus y square by 1 minus x square. Okay, done. Next, seventh question. If y is equal to sin inverse root 1 minus x square, prove that 1 minus x square dy by dx minus xy is equal to 1. Implies y is equal to sin inverse x 1 minus x square. Okay. So students, let it be for today's. Thank you. And from and 3 questions left for the substitution method question. After that I will solve logarithmic differentiation question. Okay, this question I will again repeat in next video. Okay, don't worry about it. I have some work. Okay, bye bye, tata, see you in next class.